Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello, everyone, and thank you for joining us on our third concentrator talk brought to you by the Oxygen Alliance. My name is Amarpreet Rai, and I'm currently in New York, and I'm joined by my colleagues Mteto Sinjani, Mwawi Lungu, and Timothy Matanga from Lilongwe, Malawi, and Jerry Douglas from Pittsburgh. Instead of our usual technicians, today we will have a special invited guest from the Clinton Health Access Initiative. We have Martha Gartley and Caroline Sawyers with us, and they will be talking all things cylinders. So Martha Gartley is a senior technical advisor for the Essential Medicines team at CHAI. As one of the team engineers, she has been working for over 5 years to support CHAI teams and governments in program focal countries on the technical design, development, production, and use of oxygen ecosystems, including all associated and ancillary equipment. She also provides advisory support to external partner agencies and key global donors, as well as to product developers on all oxygen-related efforts. And Caroline Sawyers is a senior technical associate on the Essential Medicines team at CHAI. She is a biomedical engineer that has been working exclusively on oxygen systems since joining the team 1 year ago. She provides technical support, including systems planning, training, and procurement to CHAI program countries that have recently added oxygen programming to their portfolio. So Martha and Caroline, from all of us here today at the Oxygen Alliance and all of our wonderful attendees, thank you so much for coming on. I think we're all very excited to learn more about cylinders and everything that you have to teach us today. So I will turn it over to you now.
Yeah, great. Thank you very much for inviting us to come and join in these discussions with the Oxygen Alliance. I'm going to let Caroline say a quick hello. I do know that she's in transit, but I just want to make sure that you guys are also aware that she's here with me as well. Caroline, do you want to just...
Yes. Hello, everyone, and thank you, Amarpreet, for the warm introduction. Really pleased to be calling in from Lesotho in transit today with one of our program teams, and happy to be on this call and be invited. So I'll chime in as much as I can in the Q&A portion and hope to be able to stay connected, but wanted to again extend thanks for being invited to join as well. Thank you.
Yes, super. So unfortunately, when we booked, we didn't have the travel portion of our work streams booked. So at least one of us is here fully able. Okay, so we were asked to give a presentation focusing on cylinders and their use in the oxygen ecosystem, in particular to touch on distribution manifolds as well as cylinder safety issues. So we've taken this ask and put together a bit of a presentation for you that might cover some of a bit more breadth of some of these topics and perhaps a bit of depth as well. From my understanding, I'm speaking to an audience of mostly technical folks, but I do recognize that different people have different areas of speciality or expertise. And so just know that if there are certain topics that I fly over or you would like a deeper dive, I am always accessible by email. Caroline is always accessible by email, and we would happily even arrange another presentation if that's what's required. Next.
Wowie, if you've moved the slide, we are not seeing the next slide.
I have actually moved the slide.
Okay. Okay, apologies for the technical. There we go.
Thanks, Molly. So this is the agenda for the presentation today. I'll start with an overview, get into some general oxygen safety, and then we'll show some illustrations of where cylinders fall within the oxygen therapy ecosystem, with a special call out to distribution manifolds. Because one of the requests was cylinder safety, we will do a bit of a dive into procurement considerations, and then we'll get into oxygen management within the oxygen cylinder management within ecosystems. This agenda slide will pop up throughout as a placeholder, dividing up the sections, and I'm not going to read it out every time we go. Next slide, please. I thought it would be important to just give a quick overview of who we are at CHAI for those that are not aware of the organization. We tend to sometimes be in the side wings of any work that we do. CHAI is a mission-driven organization committed to saving lives and reducing the burden of disease in low and middle-income countries. And we aim to sustainably strengthen government and private health systems alike in the countries in which we work. Next. Oh, that's interesting. Well, we do want to quickly flick on the next slide and see if that one came through. We might have to, yeah. Okay. Martha, do you think that we should I give it a try again by sharing my slide?
Yes, why don't you?
Okay, let's do that. So you guys might not be able to see my face anymore, but I'm going to apologies, guys. I think, we have the luxury of being able to all be in one place at a time virtually, but sometimes technology is not working in our favor to support that. So please give me a holler if you can see the PowerPoint.
Yes, we can.
Fantastic. Okay, I'm going to pick up where I left off. Are we still good?
Yes.
Okay, cool. Sorry about that. Okay, so generally our projects are very large, and we want to be ambitious to have a major impact on life-saving. A key feature of CHAI's work is that we work in direct partnership with governments. We aim to make healthcare delivery more efficient and effective, and we also adhere to a set of core values whilst we do our work. Just calling out our core values, we work with urgency, we work in cooperation with government, we are mission-driven, we are frugal, we operate with humility, we operate with a sense of entrepreneurship, we operate based on trust and transparency, we recognize that our staff is our greatest asset, and we also foster diversity and inclusion. Here are some key numbers to the organization and operations. I think to flag that 84% of our staff are in program countries. So Caroline and myself are based in, I'm in Canada and Caroline is based in the US. We are the anomaly. So I do encourage any folks that are in any countries where our programs are to reach out to our CHAI office and connect there. We have oxygen programs spanning almost 30 countries. Okay, to get into the meat of the matter, I think it never hurts to discuss some basics of the fire triangle and safety as it relates to oxygen. Oxygen is a very powerful oxidizing agent, not to be confused with flammable or explosive. It is the reason why things are flammable or explosive. And so it supports those events. So you can see that oxygen plays a key role in the fire triangle. It's one of the three sides. I did want to call out that when we talk about an oxygen-enriched environment, we are talking about an environment where oxygen concentration is greater than that of ambient air, or where oxygen concentration is greater than 21%. Seeing as we are working with oxygen concentrators, oxygen cylinders, and any other products that produce medical grade oxygen, we are definitely far above 21%. And so caution always needs to be taken when handling oxygen. Some high-level callouts on safety, just to let everyone remind everybody that grease or oil will burn in the presence of concentrated oxygen. So we need to make sure that all of our equipment, all of the connections are clean and oil-free when we work. This means we work in clean environments, we work with clean hands, we do not touch the internal parts of oxygen equipment where the product itself, the drug, will be in contact. So for example, not to put our hands in a cylinder valve, etc. Another key call out is that as we are talking in the about cylinders in particular today, the majority of cylinders are steel. In certain higher level facilities, there could be magnetic resonance imaging systems for high level imaging. And steel cylinders cannot be used near or around these devices. So we need to look at aluminum alloy products. And then I think it goes without saying, but we should put signs up everywhere that smoking or open flames are prohibited within 3 meters of an oxygen source. Suffice it to say, no smoking in any medical facilities or thereabouts. Okay. So next, some features of oxygen cylinders that I will go through. Cylinders are a container closure system. So this is a jargon for a packaging for a drug. Typically, they are made of steel, but they are found in aluminum or other ferrous or non-ferrous materials. Cylinders are designed to safely hold compressed medical oxygen at pressure. We see various working pressures, but typically around 150 is ideal in context where we are working. There are certain facilities that can fill up to 200 bar. When you're using from cylinders, you need to use a pressure regulator so that you ensure that the pressure coming out is safe to work with. We can get into this as I go along. We also want to make sure that our cylinders match with the valves that we are using in any particular geography. So we'll also touch on this as I go along. Cylinders are also open with a hand wheel or a valve key. Cylinders are described in a myriad of ways. Sometimes they are described in their water capacity, which is generally the easiest way to talk about cylinder sizes. But sometimes they are described in with a letter or with a fill volume, etc. And then cylinders used for medical oxygen should be denoted by a context-specific color. One of the more common is white on the shoulder. We do see some other variations in different contexts, and I think in the US it's green. And the last bullet here, which we'll get into in the procurement side, is that cylinders are classified and regulated as transportable pressure equipment in high-income settings. Okay, so here is probably a familiar slide to many, but if not, it's just an illustration that shows the pathway of oxygen source to the patient. And I wanted to highlight where we will see cylinders in this arrangement. So from a PSA plant, which is the source in this image, there are booster compressors that can fill cylinders. These cylinders can then be attached to distribution manifolds, which then distribute oxygen bedside via piping, or they can be delivered to the ward and used bedside. The second scenario, which is relatively similar, but a little bit different, the source here being cryogenic liquid oxygen. This oxygen is then vaporized and using a cryo pump, high pressure gas cylinders are filled. And the same as the previous slide, they are connected to a gas manifold and piped to the bedside, or they can be transported directly to the bedside for use. You'll notice that I called out a distribution manifold on the 2 previous slides. So I'm going to quickly give an overview of an oxygen distribution manifold here, and then we can get into some of the weeds about it. So cylinder distribution manifolds are regulated as a medical device in the EU. This is not to say that they are regulated as a medical device everywhere, so I just wanted to call that out. And their sole purpose is that they combine the total volumes of oxygen from a set of cylinders. So on the left-hand side, we have a bank, 4 cylinders in a bank, and on the right-hand side, we have a bank. And so it combines the volume of all of those cylinders and puts it through a pipeline distribution network. So it helps to optimize use of the resource as well as to distribute flows to the bedside. I'll also get more into particular use case in the coming slides. But just to let you know how these function, when you have the bank, let's say the bank on the left is operational, we call this the duty bank. And then the bank on the right-hand side is called the standby bank, and it's waiting. And the instrument in the middle has pressure regulation and controls. And when it senses that the pressure drops low enough on the duty bank on the left-hand side, and so that's when the cylinders essentially are empty, it will switch over to the cylinders on the right-hand side. And whether that happens automatically or manually, we'll get into those details. But I just wanted to call out that that is how it will operate. I think it is also very important to note that nothing automatically changes out the cylinders once they are empty. So you will need personnel to make sure that when a bank of cylinders is empty, we have full cylinders on standby to swap out and put them in place so that when we switch back to that bank, we are ready to go. For this slide, I recognize that there are way too many words on the page, but I will just call out some high-level takeaways, and these slides I think will be shared across the group after the presentation, so not to worry or quickly try to read everything. I just wanted to call out some key differences between automatic, semi-automatic, and manual distribution manifolds. It is common for folks to assume that an automatic manifold just does it all for you, but in actuality, the purpose of an automatic manifold is to sense what is happening with the primary supply. So an automatic manifold will be used as a secondary or a backup, and it senses what is happening in the main line, and then it will automatically kick in as your backup supply. So if we take the case of a hospital that has a PSA plant or a bulk liquid distribution, once that empties, or if the power goes out, or for whatever reason your primary supply will fail, then this secondary backup will automatically start. Additionally, there is an automatic switchover between your duty bank and your standby bank. And so that is what is meant by automatic. When we look at semi-automatic, semi-automatics have many of the same features as the automatic. However, they are designed for primary use. This is to say that it doesn't have a sensor for what is happening in the broader system should you have a PSA plant, for example, or a liquid supply. The intention is that this can be used at a higher level in the facility as your primary supply, but it will automatically switch over from your duty bank to your standby bank. And that is an automatic feature in a semi-automatic manifold. So just to recap, if you don't have an additional primary oxygen supply source, it does not make sense to spend the money on an automatic manifold. And not to be forgotten are the manual manifolds. These are a great cost-effective option. The primary difference is that you do have to manually switch from the duty bank to the standby bank. There are folks that actually prefer manual manifolds because it gives the agency to the team to really know and understand oxygen use and consumption and be sure that they know when trending changes across the day. All of these systems will have alarm features to let the user know when systems are depleting. On this slide, I'm just going to call out some of the features of manifolds, not get too into details. I've tried to match all of the 8 items on the left-hand side with visuals in the image on the right. So for number 1, we have cylinder connections. These are often copper or stainless steel pigtails. And we have to make sure that the fitting or the connection matches the valve on the cylinder. Number 2 is the high pressure header. So this is the point that connects all of the cylinders together. And you have valves on the headers to prevent any return. And you have regulators and gauges so that you can determine the content within the bank on a particular header. 3, we cannot see 3 in this particular image, but that would be if we have a manual, the handle that you swap from duty bank to standby bank will indicate just by nature of its direction which bank is in use. On semi-automatic and automatic, there will be a visual indication of which bank is in use. And 4 is the line output pressure regulator. This also is, it's on the main line above the 2 headers. So it's the combined line out that shows the regulator. 5 is an exhaust line. This is of a larger diameter than any of the other lines. And this is, should there ever be a leak in the system, facilitates rapid exhaust of the product and safely. So these are typically designed to, there's a direct outlet in the air. Number 6 is a line pressure release. So if we're doing maintenance on any side, or if you ever want to test the purity of a product, you can do so from 6. 7, you can lock. There's an isolation valve here that can be locked. And number 8 is the panel, which has the alarms and controls. Some added features for semi and fully automated are the pressure sensors, such as solenoid valves that automatically trigger valves to open and close. Okay. So the next, I'm going to get into procurement a little bit, just because this plays a huge role in cylinder safety. And when we were debating on how to present this, we thought that it would just be helpful to sort of start from the beginning when we first get cylinders into our system. And we would do a high-level overview here. And then hopefully this will be just enough to give a starting point in this conversation. Again, quite a few words on the page, but I think that just what we wanted to illustrate is that in the oxygen ecosystem, we're working with 4 different categories of products. So we have medicines, that's the oxygen itself. We have medical devices, so concentrators is, I think, one of the hot topics here, and those are definitely a medical device. We have pressure equipment, so this would be cylinders or bulk liquid storage tanks or vaporizers, etc. And then we have some additional ancillary products that don't really fit into the other categories. These would be piping, cylinder trolleys, etc. That you know, we try to keep in the same cluster as well, just because there's such an interplay and often the drug flows through, or we have to talk about the safety of our teams, etc. So this is how we generally envision the products in this space. And in a typical process, we have to make sure that all of the technical requirements are met before we will even hand over the dossier of the product for a final review by our quality teams. Because we know that from a technical perspective, if the product is not suited or designed based on what our need is, then perhaps it's not going to be helpful in safely addressing the needs of patients. Again, this one's also a bit of a wordy slide, and I'll try to get through it relatively quickly. If we want to talk specifically about cylinders, it's often a conversation that needs to really start at the point of use before, looking around to availability in the marketplace before making that initial order. And what we have found is that often this conversation is a bit disconnected. Folks that work in the technical space typically aren't engaged in those conversations at all times when procurements are made. And so it's important that we make sure that our needs are met and that we express our needs to those that are procuring the cylinders to avoid products arriving at our doorstep that just simply will not fit within our system. These could be some basics like the valves are incorrect and they are not compatible with any of the materials, or the gas supplier that we use for our facilities will not fill the cylinders that we have bought because they don't meet their safety requirements. So these are all considerations to think about before we dive into procuring cylinders. So on the left-hand side, that's more of the technical and standard piece. I'll dive into it on the next slide. On the right-hand side is the conversation that I just talked about. Who's going to be the ultimate owner of these cylinders? Where and how will they be used? Who will be filling them and who will be managing them? And then, of course, always that call out. If there is an external gas agency, we should contact them and see if they have any critical criteria, or we could be buying a product that will not be able to fit within our system. So here we go. This is that left-hand side that I showed on the previous slide. These are the working specifications that we use within CHAI when we are procuring cylinders. And I'm just going to call out right now some high-level points. We will share this with you in an Excel format, so you are able to take and use as you see fit. So you don't have to scramble to take down any notes right now. But just to let you know, so there's the section that focuses on physical attributes. Some are more critical than others, but we have the valve type and the thread. That's obviously a very critical piece. Then we have some safety features like valve protection, and then the attributes, color and size of the cylinders that meet context needs. Safety. So transport ratings are often not talked about feature. There is a UN stamp or DOT that are quite important to safely transport if any multinational, for example, will be filling these cylinders. Quality, there's the PI marking, which falls under the European TPED directive, Transportable Pressure Equipment Directive, or the DOT 3AA, that's the US-based regulation stamp. So these are, at least from when we're procuring cylinders, what we are looking for. We have cleaning. We want to make sure that these cylinders have been cleaned and are ready for oxygen service. And then if quality management systems of a vendor is in place, we want to make sure that the scope is defined. So, folks have ISO 9001 for a multitude of products, but is it indicated that they are a cylinder manufacturer under their QMS? And then last but not least, product performance standards. ISO 98091 is our go-to for design, construction, and testing of cylinders. It's a great standard, some very interesting information therein. And I'll show you, I'll do a few call-outs on the next page to this effect. And then ISO 11363 is for the cylinder neck valve threading. And this applies to the neck of the cylinder as well as the valve itself. And I've just made a call out there that will provide an Excel file for you. I think we've got quite a few engineers on the line. I'm not sure about you, but I love seeing a good drawing. I'll not get too into the weeds, but here we have on the left information that is typically found in ISO 98091. That's the cylinder ISO. And on the right-hand side is the valve. So quickly calling out here, this indicates that ISO 98091. Here we have dimensions called out on this drawing. So on the left-hand side, dimensions of the cylinder. On the right, you will, or in the middle arrow, threading. And there are various threading standards actually listed here. So you can actually see equivalence. We have material called out. So that's the material of the cylinder. And then we have down here that it has been stamped by a notified body, and this is a product that is regulated under the TPED. And then this indication on the right, the valve, I've just zoomed in here, you will see that pi mark with the notified body next to it. This has been also regulated by the TPED. So these are things that we will look for when we purchase cylinders. Additionally, cylinders are manufactured in batches, and we want to make sure that there are good manufacturing practices in place so that when you get a batch off the line, the appropriate testing has been done to make sure that everything has been done according to spec. So typically we get a certificate and various inspection reports. So here we have bulk inspection report, chemical composition report, ultrasonic exam, heat treatment, physical test, base check report, and the hydraulic test. Down here at the bottom, you'll notice there will be a match between the notified body who is endorsing these as falling under or meeting the requirements of the TPED. So this is also an important feature for us for safety and quality assurance. I've got my eye on the clock, guys. I'm sorry, I'm going over a little bit. Okay, so next we're going to get into oxygen cylinder management. Here's an illustration of cylinders as they move within a system. We know on the left-hand side, we have a point of fill, and then where the lines are in blue, these are cylinders moving in a system full. And the options for end use are distribution manifold or bedside. And then, as we all know, there's that added challenge of cylinders because they need to go back empty. And we need to make sure that the logistics are in place to get the cylinders back to the point of fill. So it's always a challenge. On this slide, I've just called out some high-level considerations when we change cylinders and when we transport and store cylinders. So as per the previous illustration, for changing a cylinder, we have to make sure that the valve is closed and that the pressure has been released, and only then can you disconnect the regulator and that accessory set from the cylinder. When we have new cylinders, we want to make sure that there is a new full cylinder, that there is no debris or dirt, oil, etc. in the valve. But again, I call out from my very first slide, we don't want to stick our fingers in these valves because our hands can be oily. So just a quick visual inspection inside the valve before connecting the regulator to this new full cylinder. And if your particular regulator has an O-ring, we always want to make sure that the O-ring is nicely in place and not warped or damaged, etc. Another challenge when sometimes we go to change cylinders and we find it really difficult to loosen the regulator set, we don't ever want to like over tighten or use a hammer or a long lever to tighten a regulator, in the same way that when we want to loosen a regulator, it should also come off by hand. So I think we're all strong enough that we can do that without the use of an additional tool. I have flagged here to not use Teflon tape on the high pressure side. That's because Teflon tape is not guaranteed to be oil free. So it is an important consideration that it is not to be used on the high pressure side, as parts can come off and combust. So a good takeaway. Another is after you've started a new cylinder, open the valve slowly, and then we can check for leaks, listening or observing the pressure gauge. Some notes or takeaways for transport and storage. We want to make sure that there's always a protective cap on the valve if the cylinder itself does not have a valve guard already in place. When transporting cylinders, to avoid rolling them on the ground, to use a trolley if and where available. That the large cylinders are always to stand upright, and especially when they're in use, they need to be affixed with a chain so they don't fall over. We want to make sure that we keep the oxygen cylinders away from the nitrogen cylinders, etc., just to make sure that we never have a mix-up when we go to give a patient their product. And then lastly, for logistics, and also for just having an overview of supply, it's always really good to keep the empty cylinders stored away from the full cylinders. I just wanted to touch on the importance of knowing your valves and what regulators to get. I touched on this a little bit earlier in the presentation, but this might be a familiar scenario to many folks. Sometimes you go to use the pressure regulator on a cylinder and you have a mismatch. So here is an obvious one where we have a pin index valve stem, and on the right-hand side, a pin index regulator and flow meter. On the left side, you have a bullnose connection. The bullnose can be also a little bit more tricky just because there are a multitude of bullnose connections depending on the standard. I have called out all the options in the spec sheet that we'll share with you after. Here is a bit of a cascade actually for making sure that you procure and or seek the correct connection. And so if you're at any point, we have on starting from the cylinder, next is the regulator, next is the flow meter, next is the humidifier. If you need, for example, flow meters and you want to understand what connections, you can sort of jump into this cascade and work your way back or forward just to see that you have the appropriate connections when you are looking to secure some extra equipment. So hopefully this cascade can help call that out for you. But yeah, as you can see, I'll reiterate the bullnose. We have 5, 6 different types of bullnose, some male, some female, and then pin index, we have a couple as well. So it does serve to take some time and figure out what the norms and standards are. I'm going to touch really quickly on the chain of custody. So that's managing your medical oxygen cylinders and that they need to stay as medical oxygen cylinders. I think that this has been quite a topic in the oxygen therapy space, not just these small subgroups or at government level or on our EBC calls. Liquid oxygen produced is one process. However, if you want to draw off of that production line, they need to have good manufacturing practices in place for medical oxygen stream. Those will then fill medical oxygen cylinders, and we have to make sure that they never get mixed up with cylinders used for another purpose. And so maintaining those cylinders in their role, from fill right through to patient side and then back again, and having documentation all the while is your chain of custody. And so this also, with the chain of custody, you have the right to ask your supplier for a certificate of analysis of the product that you are buying from them. And they have the right to ask you when you last pressure tested your cylinder. Perhaps they offer that as a service. You can do it once every 5 years. But this should be a dialogue between all parties, and making sure that you have the right documentation and the right practice for safe outcomes. And the last couple of slides are going to be on risk points. Again, we have quite a few words on a page here, and I don't want to sit here and read them out. Some of them we've touched on lightly as we go through, but just calling out that there are, I've done three broad buckets for risks. One is at the point of distribution, so when oxygen is actually being used from the cylinders. And it's not always related to an oxygen enriched environment where we have to make sure that we do that in a smoke-free, spark-free, oil-free environment, but also that injuries caused by falling cylinders. So, to reiterate, if your cylinder is in use, have it chained up. If you're transporting it on a trolley, make sure it's chained, etc. Ways that we can also mitigate any leakage is making sure that you inspect your valves. So I had called out even that visual inspection when you're first putting a regulator onto a fresh cylinder, always good to check that. But of course, any valves in a manifold or on a pipeline are really helpful to ensure that we have no leaks in our system. Cylinder filling is a really interesting point where we have some risks and also some baseline practice to mitigate them. For filling, it's always really important that we have an evacuation vacuum. It's a small little compressor, and that will make sure that you empty the cylinders of any final residual oxygen prior to filling. We also want to make sure that when you are filling cylinders, that you always do it in batches. So you don't take cylinders off or put cylinders on mid-fill. And we also wanting to make sure that the connections are appropriately made before you start your filling. So making sure that everything is appropriately tightened, etc. And then, of course, the mitigative measures are just, again, double checking everything, making sure your valves are in good shape, your O-rings are intact and also well positioned in their seat, and that you don't ad hoc add and remove cylinders as you go, as I said. That one's a pretty important one. And I think also refresher trainings. It never hurts to have discussions and just make sure that everyone is continuing with the processes that were set out as their standard operating processes for any of these works. And then last is cylinder delivery. I think, we've all seen cylinders being rolled everywhere or sort of tilted on the side and walked across a floor. Cylinders weigh, 70 plus kg when full. It's people can break limbs, you can crush a foot. There's just no reason to rush and do this if we can get the proper trolleys and make sure that the cylinders are chained into place. I think also for when you're transporting cylinders on trucks, we just want to be really cognizant of payload because we know vehicle accidents are quite high. If there's a vehicle accident with a whole bunch of cylinders, we're looking at a case of projectiles that can, cause more damage than the accident itself. So just making sure that when cylinders are transported in a vehicle, they're done upright, they are strapped down, and that you under no circumstances overload the vehicle. And I'm going to leave it with a bunch of do's and don'ts. So these are some summary of most topics covered in this talk. I don't think any new messages here other than, I've got test tags or barcodes, and these are if you have a system for asset management for the cylinders. That's the only one that's a new call out here. But on that, we've reached the end. Thank you for listening.
Thank you very, very much for that wonderful presentation, Martha. We've got now a few minutes for questions or comments, and as people are getting their questions or comments ready, I just want to remind you all that next week we will go back to our regular programming with the concentrator talk. And if you are new for this oxygen talk, what we do with the concentrator talks is focus on concentrator repair and maintenance. So if you would like to be included in further meetings, emails, calendar invitations, please do drop your email in the chat. We do, as Martha said, do a very good job of putting everything on our website and sending you a fair amount of material by email. This presentation will be on our website. You will be able to access it. The recording of this video will also be there as well for when you need to quickly review something. And we will also include the different material that Chai uses that Martha talked about as well, so that you have access to everything on an easy to find place, not just in your emails. So please, any questions or comments? Vikas, I see that you've put a note in the chat that you might want to comment on. And please just raise your hand if you have a question so that we can do it in an orderly way. Martha, while we're waiting, do you want to comment on this? And I'll just read it out. So Vikas has put a note in the chat that says, valve should be opened smoothly to avoid adiabatic compression and heat generation.
I would only add to that slowly and smoothly. Yeah.
Do you want to just explain what adiabatic compression and what the concern would be here?
Yeah. So you have a lot of product at high pressure in the cylinder, and if you automatically allow that product to very quickly expand, you will have exactly what Vikas is saying, where you have a rapid event of heat generation because of the ability of the gas itself to go from a highly compressed state into atmospheric pressure. And so there are risks associated if you would just rapidly open the valve. And so exactly as Vikas has said, open it smoothly and open it slowly. Also, when this happens with the pressure release, you will also have the regulator self-tighten. Again, because right now at this point, we've tightened the regulator on by hand. So that's another reason why we want to just make sure that we open it slowly and smoothly with care.
Wonderful. Thank you very much. Do we have any other questions or comments? Okay, I am happy to ask one, Martha. There's a lot that, well, okay, before I get to my question, we've got one from Alpha in the chat that says, why do other plants use of vaporization, not just as other plants? Alpha, I'm not sure about that question. Do you want to come off mute and explain exactly what your question is?
Okay, I understand that other plants, they use vaporization, as she said it, and it's different from the plants which are usually normal, like other plants. I don't know if you get it.
Yeah, absolutely. So Alpha, I think if I understand correctly, a PSA plant, a pressure swing adsorption plant, operates using the same technology as an oxygen concentrator, and it pressurizes ambient air, adsorbs the nitrogen, and the compressed oxygen leaves the plant or a concentrator as a gas already. And so that is, you can repressurize that gas and fill cylinders. Another modality of producing medical oxygen is cryogenically using fractional distillation. So I'm going to break down those words. If we take ambient air and we drop the temperature down into the negative, below minus 180 degrees, so very cold. At that temperature, you have the ability to selectively remove the different constituents of ambient air, but it's also at that temperature when it has changed state from gas to liquid. So that is also known as liquid oxygen. And the product of those liquid oxygen plants is oxygen in liquid form. But of course, you don't ever administer liquid form to a patient. We need to get it back into gas form before we can give it to a patient. So that is why we use a vaporizer, and it allows for the liquid to pass through a series of fins and have enough contact time with ambient conditions so that it can self-transform or self-state change back into gas, and then we can use it in its gas form. So there are certain contexts where this is available, and we can also use this gas to fill high pressure gas cylinders as well. Did that help to answer your question?
Yes, it did. Thank you.
No worries.
Thank you, Martha. Our next question that we have here from Gretchen. On one of the slides, you talked about not using Teflon on the high pressure side. Can you explain the risk of using Teflon? Because I have seen it a lot in our facility to recycle the pressure regulators.
Yeah, Grisha and I have as well. And, oftentimes when we have, resources where we have to make the match for functionality, not all Teflon tape has been properly or adequately degreased. And it's important that your Teflon tape has been degreased so you do not have a risk should a piece of that, sometimes when you see it wrapped around those threads, there are some loose bits that can then enter into the pathway, the gas pathway. And if the Teflon tape has not been rated for medical use, you could run into some issues if it's not been degreased properly. So I would say that, likelihood is probably quite low, but potential issues could be big.
Thank you, Martha. Is there an alternative because Teflon tape is, of course, easily accessible everywhere, right?
Yeah.
Is there an alternative that maybe this facility or another facility, because I suspect this is quite common, especially where our technicians and our Auction Alliance members are located. So is there something else that might be equally as accessible or almost as accessible that can be used instead more safely?
It could be an exercise actually for us to explore, the folks that do straddle the supply and the use side of things, to see what the prevalence of Teflon tape that has assurance of degreasing, for one. For two, I don't want to make any, how do I say, unsafe recommendations. However, I think that if folks are very careful with, oftentimes you see threading that has been wrapped and then rewrapped and then rewrapped and then rewrapped and then rewrapped. So just to kind of urge people to be really careful and cautious of any threading wrapping, that it's always done against the thread. But then also to note that if you actually have any damage to the threading, and if that's what you're trying to mitigate with the Teflon tape, really we should pull those regulators out of service.
Wonderful. Thank you, Martha. I see a hand from Vikas.
Hello, this is Vikas from India. I don't have a question. I just want your suggestion, Martha. Like during second wave, India have received a lot of cylinders from foreign countries, and we don't have exact paper, what we can say specification paper of that cylinders. So what we are facing right now, I'm working with government of India. So what we are facing, like how to convert this cylinder into Indian compatibility, and if we are doing HST like hydrostretching test or weight loss test, so the vendor asks for the specification paper. So I just want to know how we can proceed for operationalization of these cylinders in my country.
Yeah, Vikas, that's a fantastic question, and that involves a bit of digging for information. And it's, I think, a challenge that is faced by many, probably not to the same extent that is experienced by you right now in the government of India, especially after that huge wave. So working backwards on a cylinder, and I actually didn't include a slide on this, but I'll see if I can try to explain this swiftly. On the shoulder of the cylinder, around the top of it, you have a hard stamp. So you have all of the manufacturer should be stamping the name of the standard that they use. They should be stamping their manufacturer name, the test pressure, the first test date, the working pressure, and a whole multitude of other pieces of information. This is a fantastic starting point to start putting together cylinder-specific specifications, and only from that point can you start to match up with what, you know, whether or not it will be compatible in India's system. And if not immediately compatible, are there mitigative measures that can be put into place? As you said, doing an additional hydrostatic test or doing a cleaning, etc. So I think that there will have to be probably a cascade of steps for you to manage this particular challenge, but there definitely are some approaches, and I will happily share with you that shoulder work as well as some of the steps that we have taken when we've had a similar challenge.
No, actually, I have gone what you have told, na? Like there is a stamp top company or the specification, the working pressure is mentioned on the neck of the cylinder. So what I found, like I have worked with many cylinders, like I have worked with which are donated by USAID, which are donated by European Unions. So some of the cylinder have that mark. So I have worked accordingly to alternate it, but I most of the cylinder I can say the marks are not there, so I'm facing difficulties in that cylinder.
There are no marks at all?
No.
Oof. And do you have any idea who the donors were, or they are now totally lost in the system?
Actually, we have received these cylinders during second wave. Na? That's lot of case load in India. So
Yeah.
government is also don't government did not bother to get the documents or whoever are donating this cylinder. They just received what cylinder from wherever they got. So we don't have right now. We don't have any document regarding that, and not even dot specification, the pi specification. I have worked on it. I have gone through many international documents, many guidelines, but unfortunately, I am not able to convert 100% of cylinder into according to Indian standard.
Yeah, because that's a really challenging situation, and I think that it would require developing a risk analysis, and a decision will have to be taken.
Actually, right now I'm doing the same.
Yeah.
What we can do and what we can do with regulatory bodies to alternate this to solve these situations, these challenges in India.
Yeah. Yeah. Well, I'm happy to have a brainstorm with you if you would like. We can connect offline.
Because
Sure.
Sunil Malvi from this side, PESO has issued lot of directives for the cylinder testing and converging and received from the Foreign Aid. They have issued some guidelines. PESO, PESO,
Yeah.
Petroleum and Explosives Safety Organization issued directives for the received of the Foreign cylinders.
Okay. So I have gone through Sunil PESO guideline, and they have mentioned that cylinders should be tested accordingly ISO 13485. Okay. Yeah.
So,
But the cylinder which have the dot
Vikas,
specification, this cylinder
I'm
are
so
only
sorry,
able to.
Vikas. We are unfortunately out of time. This might be
Yeah.
something, Sunil and Vikas, it would be great for you guys to connect perhaps and discuss what the possibilities are in India going forward to solve this.
Sure. We will connect
Yes.
later.
So thank you very much, Martha, for your time today. I'm just going to drop a few links in the chat. So one is our YouTube channel, where you can find access to this recording in the future and a lot of our other concentrator talk videos and components. Our website as well, where you can find a lot of information, and of course our email address. So thank you so much, Martha, for your time today, and thank you everyone else for joining and listening and learning with the Auction Alliance today. Thank you. Bye-bye.
Thank you.